It's a city that never sleeps, and the high-rise light show is one of Shanghai's big attractions. But it's costly. Lighting burns a lot of energy. Over 20% of the world's electrical consumption is to light our buildings and homes. But here in Shanghai, there's a new bulb in town. These lights last up to 100,000 hours. Compare that to the incandescent bulb that has only 1,000 hours of life. They're called induction lamps, and some say they're the best kept secret in lighting. A second-generation light bulb manufacturer that churns out over 2 million bulbs a year. The induction light is an energy saver, but that's not all. On the left is a metal halide bulb. On the right, sodium vapor. Notice the light in the middle doesn't flicker. That's the induction bulb. And that's not all. It gives off less glare, can be used with a dimmer, and doesn't generate much heat. Production is spread out over 3 factories. One to make the bulbs, another to make the power supply, or ballast, and a third where all the parts come together. It all starts at this 5,000 square meter bulb factory. 30-centimeter lengths of hollow glass tubes are fed into a super hot oven to soften them up for bending. Timing is crucial, because at the end of this 35-second ride, it's a blazing 1,500 degrees Celsius. A second too long, and the tubes could melt. The glass tubes get swallowed up and curved into a U. It's here the bulbs begin to take on their donut shape, or at least half of one. Next, it's down to the conveyor, so the tubes can gradually cool down to room temperature. The straight ends are cut off, and the half donut tube gets washed to make ready for another bath, a milky coating of phosphor and glue. It's the phosphor that gives the bulb its bright white color when it lights up. A 600-degree oven speeds along the phosphor drawing process. Then the 2 halves of the glass tubes are joined. But before they're put together, here's what makes the induction bulb so unique. There's no electrodes or filaments inside. Filaments burn out. In fact, it's the biggest cause of failure for more common bulbs. The question is, if there's no filament, how does the induction bulb generate light? More on that in a minute. Time to bring the half tubes together, sealed tight with 1,200-degree heat. Next, the bulb must be drained of any remaining air. A small tube jutting out of the bulb is fused to a machine that vacuums out the air. Then argon gas is fed in. That small protruding tube serves another purpose. It's the sealed housing for hard pellets of solid mercury, about the size of a bean seed. When powered up, the mercury gets excited and vaporizes inside the bulb, producing ultraviolet energy. The invisible UV energy bounces off the white phosphor to produce light. The light bulb's power source is a ballast that produces a high-frequency current. With no filaments to burn out, the life of the induction lamp is mostly determined by the ballast. This ballast is a radio frequency power supply that starts with a circuit board. Each one has a diagram or roadmap showing where all the diodes, capacitors, and transistors go. The boards are fed into a machine that installs some of the smaller components. These robotic arms work around the clock, spitting out close to 3,000 boards in a 24-hour period. The board is inspected to make sure the components are secure and in their proper position. Workers attach the remaining components, 100 in all. Then it's a slow, hot ride to get ready for a sizzling bath. A pool of 250-degree solder welds all the connections underneath. Once the boards cool down, it's inspection time. First, a visual once-over to check for any missed solders. Then into a defects analyzer to check for missing or loose components. If it passes, the ballast is ready to be united with the bulb. And for that union, we go to the assembly factory. where 6,000 bulbs and ballast are brought together every day. First, workers wind a length of aluminum coil around a magnetic ring. The magnetic rings are the key to induction, which means the transmission of energy via electromagnetic field. When the coil is powered up, it produces a current that surges through the magnet, generating an electromagnetic field around the bulb. It's this field that excites and vaporizes those mercury pellets to produce UV energy, which strikes the white phosphor to create light. While the coil and magnetic rings are being made, the bulb gets a few quality checks. First, to ensure there's no leaks or cracks, the pinkish red color confirms the vacuum is intact inside the bulb. Then, the bulb is fired up to ensure it's generating enough wattage. Bulbs range from 15 up to 200 watts. Next, the magnetic rings are carefully fastened. Tighten the rings too tightly and the glass can shatter. Too loose and the amount of magnetic energy generated is weakened. To make sure the magnetic ring is secure, the bulb is tested once again. The machine on top measures electrical output. The bottom one reads voltage. On another line, workers put the finishing touches to the ballast. The circuit boards slide into a protective aluminum casing, and the voltage tested for output. Now, the final test. The bulbs and ballast are connected to a conveyor. They will burn for 2 hours and brightness and wattage measured. Notice, as they come off the line, it's a matter of seconds from when the bulbs turn off to when workers pick them up. That shows how little heat they generate. The bulbs are exported to Europe, Asia, and North America, including San Francisco's Golden Gate Bridge. The Shanghai Hongwan Lighting and Electric Company is working on an induction light for home use. This one burns for up to 60,000 hours. With more and more countries banning the incandescent bulb and consumers looking for more efficient lighting, it's a safe bet the induction lamp won't be a secret for much longer.